Most of you have probably seen the movie Oppenheimer by now, you know, the guy who created the atomic bomb. But have you ever wondered how this thing actually blows stuff up? I mean, it sounds simple. You take a uranium atom and split it and boom, explosion, right? Well, it's kind of more complex than that. First, let's understand how a normal bomb works. A bomb, by definition, is a container filled with explosive or incendiary material designed to explode on impact or when detonated by a timing, proximity, or remote control device. Cool, right? Let's build one. Most conventional bombs today use either TNT, RDX, or, well, oxygen, or ammonium nitrate. So now what? We have some explosive powder now. How do we detonate it? So an explosion simply is a sudden and violent release of energy. How do we do that? We use chemistry and physics. Let's say we have TNT. TNT contains elements of carbon, oxygen, and nitrogen, which means that when the material burns, it produces highly stable substances. However, TNT in itself is chemically unstable. The nitrogen groups are closely packed, so they experience a lot of strain and they have a very restricted movement. This also means that it doesn't take a lot of initiating force to break some of those strained bonds. The molecule then fucking flies apart and you get the, well, explosion. So in order to initiate the explosion, TNT must first be detonated using a pressure wave from another explosion. So you basically use an explosion to make a bigger explosion. However, the thing that detonates TNT is a detonator. One such detonator could be lead acid. Lead acid explodes when struck or if an electric discharge is passed through it. Then you just need a fuse which slowly burns until it reaches the detonator. The detonator then initiates the explosion of the TNT, and the atoms in TNT don't really like pressure, so as a result it explodes and you have a explosion. So now, how do atomic bombs work? They're actually quite similar, yet completely fucking different. So, for an atomic bomb, you need fissile material. Fissile material, in other words, means material that is capable of splitting the very atoms that it is made of. How does that work? You basically throw a neutron at a nuclide and then the nuclide splits, releasing other neutrons. Those other neutrons collide with other nuclide, which in turn releases even more neutrons. And so you have a nuclear fission chain reaction, which is kinda cool if you want to build a highly explosive bomb. Two such fissile materials would be uranium and plutonium. Once you have either of one, you need to quickly assemble the material into a critical mass, so it reaches criticality. How the fuck does that work? Criticality is vital if you actually want the atomic bomb to detonate. So you need to get enough uranium or plutonium to ensure that those neutrons released by fission will strike another nucleus and therefore producing a chain reaction. So the more uranium you have, the greater odds that such an event will occur, because the neutrons have more chances to hit another nucleus because there are just more of those. But wait, remember how I said you need uranium? Well, you still do, but it's kinda important that you get the correct one. Most uranium in the world exists naturally as uranium-238. Therefore, only about 0.7%-ish of naturally existing uranium is the uranium-235 isotope. If you try to build an atomic bomb with uranium-238, it would be pretty useless because when a neutron hits the uranium-238 isotope, it just absorbs the neutron like nothing happened, and therefore failing to do fission and of course not initiating a chain reaction. To get uranium-235 in a nutshell, you throw them into a hot liquid bath and voila, uranium-235. Of course, it's a lot more complicated than that, but let's move on. Now, before we get onto the detonation of nuclear bombs, let's first explore the concept of chemical explosions. Let's say you have a hydrogen atom and an oxygen atom. You have both components for water. Now let's say you put them in a container and heat the container. Atoms begin to move faster the hotter the temperature is. Because the atoms move faster, they collide with each other. The hydrogen atom loses electrons and those electrons get absorbed by the oxygen atom. When the electron flies apart and reunites with a different atom, it carries a lot more kinetic energy and therefore it begins to spin and to move even faster because it has excess energy. That means that all of the surrounding neighbor atoms also begin to spin faster and move faster, which also means that the neighbors of the neighbors begin to spin faster, and eventually the whole thing is moving faster as a whole than before, and you get a lot of heat. So the more speed you have, the more heat you get in the case of a chemical reaction. However, a nuclear reaction doesn't have anything to do with electrons. It only has something to do with the nucleus of an atom, like we discussed before. Let's scale up a uranium-235 atom to the size of a football field. The nucleus will only be about the size of a ping pong ball on the whole football field, which is pretty tiny. The rest of the football field will be covered with spinning electrons, which you don't really see because they're kind of invisible. Now imagine shooting a neutron from outside the football field in 3 random directions. We're probably not gonna hit the uranium-235 nucleus. Not good. So how do we do it that we can hit the nucleus? The easy solution is to get more, well, uranium-235, because then the probability increases that one neutron will hit a nucleus. Once you hit a nucleus, it will split up and on average spit out 3 more neutrons, which in turn have the potential to hit other nuclei. So to get a chain reaction, at least 1 out of 3 neutrons have to hit another nucleus to keep the chain reaction going and to be self-sufficient and self-sustaining. However, this gets out of hand pretty fast and explodes only after a few collisions, and the explosion won't be that big. So what you do is basically something called an implosion. You use regular explosives and you surround it at the uranium core. You then get the timing perfectly down to microseconds, and you detonate. The pressure will smash a uranium canister into the bomb, which will set free lots of neurons at the same time, and not only 1 or 2 at a time. This way you can have neutrons smashing into other nuclei at the same time, and therefore use the limited amount of time that you have more efficiently by doing multiple collisions at the same time. So after a while, and that while is less than a second, the pressure and heat becomes so extremely high that it just wants to get the fuck out of there, and in turn this creates a huge plasma ball that you see in the first few microseconds of the explosion, and then, well, you better hope you're far away, otherwise you're kinda dead. So yes, that's how you build a nuclear fission bomb, in a nutshell. Now there are also hydrogen bombs, which basically are atomic bombs on crack. They're not fission bombs, but they are fusion bombs, so you fuse atoms together, more specifically hydrogen atoms, but that's a topic for another video, and in the meantime, I'm gonna head out.